Alright guys, so today we are going to be solving Leetcode 1 to sum. The question says that given an array of integers nums and an integer target, we want to return the indices of two numbers such that they add up to that target. And the assumption here is that there would be exactly one solution in the array of nums that is given to us. And so we can assume that there would always be two elements that would add up to the target, right? So here is an example of nums 2, 7, 11, and 15 and a target of 9. And here we can see clearly that 2 and 7 add up to 9, and hence we are supposed to return the indices of 2 and 7, which is 0 and 1. All right, so here we are going to rely on the relationship between addition and subtraction. So suppose we have two numbers, a and b, that add up to the target. This means that a is essentially equal to target minus b, and b is equal to target minus a. So what we are trying to say is that for any given number, the number to be added to it to get a target is basically the target minus that number. We can refer to this as the complement of that number. So for this question, we'll go through the array that we have been given, and then we'll keep track of each number and the ID, the index of that number in the array, because each number could be a possible complement to a later number that we would find in the future. So what we'll do is that for each of the numbers that we find whilst we loop through the array, we will check if we've seen its complement before. If yes, then we've got a solution, because we'll just return the current index that we are on and the index of the complements that we have seen before, because we are keeping track of that in a hash map. All right, so we are going to define a map here, starting from an empty map, and then we are going to loop through the array using the index. So for I in range length of nums, what we are going to do is to calculate the difference, because that would be our complement. So difference is equal to what? Target minus the number at the index that we are currently on. And then if this difference, if this complement is already in the map that we have, we want to basically return the current index that we are on, I, and the index of the difference in the map, because that would be the index of its complement. But if this is not the case and the difference is not in the map, which means that we've not seen its complement yet, we want to add this number itself to the map, because it could possibly be a complement for a future number. So we do map, and then we add the number as the key, nums at I, and then we add its value as the index, so that we can use it as we are using it here when we actually find it as a complement. And that should basically be it. We don't need to do anything if we go through the array and we don't find anything, because the question says that we are guaranteed to find at least one solution. So we are guaranteed that once the loop finishes running, we should have our solution. Run it, so that's it, all test cases passed, and then we can submit this as well. Yeah. So the time complexity of this algorithm would be O of n, and this is because we are going through the array of nums that we have been given only once, and we are doing basically the same thing for all of the numbers that we find. So the worst case scenario is for us to run through the array without actually finding the solution, but we are going to find it anyway. So, and the space complexity is also O of n, because we are keeping track of all of the values that we are seeing in the array of nums that we have been given over here. So anytime that we don't find a solution, we keep track of that number and its index. So as the number of elements in nums grow, the extra space that we use also grows. And so the space complexity of this is O of n.